Early in this software series, we talked about a principle called the Single Responsibility Principle, or SRP. And hopefully you remember it, but it basically states that methods and classes should only have one responsibility in the software system. So if you start describing the purpose for any given method or any given class, and you use the word "and" at some point during that description, then that might be a signal that you're trying to accomplish too much in that given method or in that given class. And so let me give an example. You might have a method and you say, this method determines the result and it formats the result for display. Well, those are really two different responsibilities. And so you might want to break them up into two separate methods. In fact, I gave you a little rule of thumb to help you understand whether you're doing too much in a single method. I said that no single method should have more than 6 lines of code. And sure, rules are meant to be broken, but that at 6 lines of code, that little trigger in your mind should go off, and it should remind you to take an honest look at the code and see if you're trying to do too much. Furthermore, I said that some people that I've read and heard from believe that no single class should have more code in it that runs off the bottom of the screen. So any class you shouldn't have to scroll to see the rest of the class's code. And again, I don't know that I would go quite that far, but the point is not to create an explosion of the number of classes in your system, which is probably what would wind up happening, but rather it's to force yourself to ask the critical question, am I trying to do too much in this class? So if you follow these little rules of thumb, I guess you could call them, they're going to help you achieve a high degree of cohesion in your classes. In other words, your classes are laser focused. Every line of code that's in that class has to be in that class. So talking about principles at a higher level, principles apply regardless of the programming language or the platform that you're working on. The things that we talk about with regards to single responsibility principle apply in JavaScript and Java, Ruby, C++, and so on. They've been around for decades, and they've proven time and time again to be some of the best guidance that can be offered to new software developers. And so there's another principle of software design that is applicable regardless of the language or the platform, and it's called separation of concerns, or rather SOC. So you separate the concerns of an application in an effort to make them more resilient to change. Change is the sworn enemy of software developers, and yet we face change every single day. Changing business requirements, changing the code to fix issues in it, changing APIs that we were pointed to an old version of an API, now we need to change to a new version of an API because the vendor decided it was time for a change. Or changing entire platform dependencies. I was relying on .NET and now I'm going to rely on WinRT. Yeah, there's similarities, but there's also differences. So change is inevitable, but we can mitigate the impact of change by separating the concerns of an application. So what do I mean when I say concern? Typically, that breaks into several well-known layers for most software or programs that you create. However, there may be additional concerns that depending on the architecture of your given application. So there are just 3 canonical examples that we'll talk about, but in reality there could be many more layers. So in this video, I'm going to talk about this from a very simplistic perspective, but rest assured, I have an entire series on this topic called Application Architecture Fundamentals that delves into all these topics a great deal, and I highly recommend that you stick with the curriculum. It's at the very end, and it's probably some of the most important content that you can watch. You can go ahead and peek, but some of it may not make quite as much sense just at this point. But for now, it's sufficient to think about the major concerns of your application in terms of those 3 canonical layers I referred to a moment ago. There's the presentation layer, the domain layer, and the persistence layer. So the presentation layer is concerned with display logic. How do I take data and display it to the user in a way that they can consume it? All right, very generic terms here. Then there's the domain layer, and that's concerned with the domain logic. And when I use the term domain, I'm simply using that as the business domain or the problem domain. You know, if it's to inventory a warehouse, then you would have crates and shipments and things of that nature. Those are the domain objects and the concerns regarding, how many items are on hand and things of that nature. All right. So you're concerned with the domain or the business logic of the application in the domain layer. And then finally, the persistence layer is concerned with the permanent data storage and the retrieval of the data. So up to now, we haven't really saved any data into a database, but we're getting closer to that. So let's table that idea for just a little bit. We have been writing applications that have both presentation concerns and domain concerns. The presentation concern in an ASP.NET web form API are things like the actual ASP.NET syntax, the special syntax where between the angle brackets inside mixed in with the HTML. There are also the ASP.NET server controls, which are an API that is made available to you when you create web form applications. Then there's the whole ASP.NET event model, which we haven't really gone through yet, but you've seen things like the page load and the click events and things of that nature. So all of those are presentation concerns, and they're mostly taken care of for us already by Microsoft. They're code that we rely on, but we didn't write. However, we do write presentation logic whenever we accept input from a user and then do something with it, or when we need to display information to a user. So that's the presentation layer. The domain layer, or the domain layer concern, is all the business logic that we write. There are calculations and decisions and looping and the creation of classes for the major domain objects. Things that we've created in the past, like the character class or like the hero class or the weapon class, things of that nature. These comprise the core logic of your business encapsulated in the code that you write. So oftentimes a software developer will come to understand how a given business operates more intimately than subject matter experts that in the industry that work in that business every day. And the reason is that developers have to come to know every possible decision or consideration in order to automate it properly. So they ask critical questions and force business owners, and by that I mean from an internal perspective, not necessarily the president of the company, but people that your clients essentially, who are sponsoring the creation of this particular application. You have to come, in essence, to know it even better than they do, and force them to answer hard questions like, in this scenario, what do you do? In that scenario, what do you do? And coming back to layering your application at a higher level, if you do it right, you should be able to completely replace the database technology that you use without upsetting your domain layer. And you should be able to remove the user interface and replace it with some other technology, and your domain layer would still work. And so this would be the true embodiment of the principles of separation of concerns. Now, if you recall way back in Lesson 41, creating class libraries and adding references to assemblies, do you remember that? I demonstrated how I was able to create a simple class library. I moved some code into that class library, and then I called the methods of the classes inside of that class library from both a web forms application and a WinForms application. You remember that? That was pretty cool. And that's one of the tangential benefits of separation of concerns, but let me get back to that in just a moment. You might say, I doubt that I'm ever going to need to do something like that. Why, after I wrote an application in ASP.web Forms, would I want to use some other user interface technology? Or if I'm using SQL Server, why would I ever change from that and use another database? Well, you might think, I'll never use that. I'll never do that. First of all, never say never. You might find yourself doing that because things change frequently. I mean, in my 20 years as a software developer, following only Microsoft, there have been at least a dozen different display technologies, probably more than that, and probably half a dozen different ways of accessing database, new APIs that come out every 2 or 3 years to access a database in a more efficient manner or make it in a coding style that that is more in vogue today. Okay. So that's the first thing. Never say never. And then secondly, I would say that this isn't really about swapping out entire layers, even if that's something that you could do. Code reuse definitely is a huge byproduct of following the separation of concerns principle, but it's just that. It's just a byproduct. The real benefit in separating your concerns strictly is in writing applications that are resilient to the inevitability of change. So whenever you separate your concerns and use that as a guiding principle in everything that you do, it's going to help you organize your code in such a way that it can be grown to a massive sized code base, yet still be maintainable. If you follow the separation of concerns, you have a clear guidance on where code belongs in your application's code base based on the concern of that given line of code or that code passage. Honoring the separation of concerns will help you avoid common beginner mistakes. So for example, many developers, myself included, would create applications where the user interface is tied directly to the database with a little bit of code mixed in the middle to glue it all together. However, then the first time that the customer says, hey, that's awesome, but could you add this and could you change that? Well, then you quickly realize that your code isn't resilient to change. When you have to change things about the database and that breaks the user interface and you're like, oh my goodness, now what do I do? And typically that requires a rewrite if you're an inexperienced developer. And that's why so many projects require a rewrite after their initial implementation. The developers didn't anticipate change, and it's inevitable. They didn't embrace the change. They didn't use the principles of separation of concern to manage the change. Or consider another beginner scenario. Again, I'm guilty of this. I did this when I was first getting started. You've sprinkled some business logic in one web form, in maybe your default.aspx, and then in your second web form, page2.aspx, you've sprinkled a little more business logic, and then you give it to the business owner. He says, this is awesome, but I need a third page, so we'll call that third.aspx, and it's going to basically do the same things as the first two pages, except I need a few little changes on it as well. So now you find yourself copying code from default.aspx, copying code from the page2.aspx, and making a few changes, and you're starting to get a real mess on your hands here. If you've got to change any of the business rules, now you're changing in several different places. It's just not a very good idea. So, honor separation of concerns. Why do I bring this up? Well, we're going to start building applications, first of all, that utilize programming constructs like exceptions. It may not be readily apparent to you why you would want to create a custom exception or why you would want to throw an exception. I mean, why would you want to create an error in your code? Well, this background, understanding separation of concerns, understanding the layering of software, will help me explain why you'd want to do these sorts of things. That's number one. Number two, we're going to start building applications that utilize data storage, different kinds of data storage. Admittedly, it's going to be a simple data store at first in Azure, and you can get a free Azure account. We'll cross that bridge when we get to it, but it's going to be some data store. And it would be cool if we could start with Azure Storage Tables and then migrate to Azure SQL Database or an on-premise SQL Server installation and not have to rewrite other core pieces of the application like the entire domain concern, the domain layer, or the presentation concern, the presentation layer. All we did was just swap out which database technology we're going to use. And then later in the curriculum, we're going to start talking about unit testing. You cannot unit test successfully without understanding the importance of separation of concerns. Now, ideally, you would package your concerns separately. When I use the term package or packaging, I mean in .NET parlance, .NET assemblies that your code is compiled into. Or in the case of an ASP.NET presentation layer, perhaps there's many ASPX pages along with one or more DLL assemblies, .NET assemblies. Basically, whenever you have a package inside of a solution, that will create a package, whether that be a class library that creates a .NET assembly, a .dll, or like I said, an ASP.NET Web Forms project that'll create a bunch of different files, but essentially it's packaged together. So you have a package, or rather you have a project and a solution. That project creates a file when it's compiled, and that's the package. While this tactic is not strictly required, I mean, you could put all the layers of the application in a single project, and many people do that. Separating your layers out into separate Visual Studio projects will help you reinforce and remind you what you're trying to accomplish here. So, separation of concerns. From this point on, I'm going to be illustrating this idea by being mindful of the given concern of the application, and I'm going to put it a given concern into one of two projects. So let's talk about, I'm going to remind you something that we did way back in lesson number 5 when we created a solution and added projects to it. And I said it may not be obvious now why you'd want to do that. Well, today is the day where we want to do that and why we want to do it. So I'm going to go ahead and click New Project. I'm going to create a new solution. So I'm going to go down here to Other Project Types, and I'm going to give this the name Some Project. And I'm going to make sure I select blank solution. Okay. Let's actually call this Some App instead. That might be a better way to go about this. I don't want to overload terms and confuse anything. So I'm going to pull the Solution Explorer way out here so you can see it. And I'm going to right click and I'm going to select Add New Project. And this time I'm going to go to Visual C#, I'm going to go to Web, and I'm going to create a new ASP.NET Web application. And we're going to call this Some App dot web, and that's a common convention for creating projects to give it an extension like .web, or in a moment we'll use .domain and .persistence. Empty web forms, don't host it in the cloud. Okay, so we have our first project. Our second project we're going to add to our solution is actually in the Windows category. It's going to be a class library, and we're going to call this Some App dot Domain. And I'll click OK. And so this created another project for us, and whenever we compile, the assembly will be called Some App dot Domain dot DLL. Okay, and then finally at some point we're going to add a new project and go back and create another class library, and we'll do Some App dot Persistence, and or data is common as well. And so this project will be all about managing data in and out from our given database technology. It'll kind of wrap around it. Now, later on, we may add other layers too, or in your particular application architecture, there might be a web services layer. There might be a layer that wraps around some external API. So, for example, maybe you're going to create an e-commerce system and you're going to integrate with PayPal, or you're going to integrate with Stripe rather. So you might want to write a whole layer of software that wraps around it. So you might do Some App dot Payment, for example. And so all the classes in there would just wrap around and interface with the PayPal API. Now, if we ever choose to use a different payment provider, all we got to do is swap out that payment layer and use a different vendor. Or we could wrap around Facebook or Twitter to mitigate the possibility that there are changes eventually in the APIs that Facebook or Twitter expose. Now we have buffered ourselves away from that, and we don't have to touch all parts of our application. We just expose common interfaces, methods, and properties, and behind the scenes, our project that's called SomeApp.Facebook will worry about the implementation details of the new API that Facebook has deployed. Okay? So, to recap, this was just the first mention of many of the principle of separation of concerns. I wanted to introduce it now because I'm going to start using it to divvy up the responsibilities of our software that we build into the proper projects representing the layers, or rather the concerns of the application. And this will allow us to talk about exception handling and unit testing and a lot more. Okay? Hopefully that makes sense. We'll start that process in the very next lesson. See you there.